Hello students, how are you? I hope all you are doing good. Today we're going to solve the BPT 5 test paper. My name is Aviraj, I am your physics SME. I will solve the physics section. Without wasting your time, let's get started. First we will look after the question, understand the question. Thereafter we will look after the explanation to it and then solution of it. Moving to our first question. It says a Wheatstone bridge has resistance of 10 ohm, 10 ohm, 10 ohm, and 30 ohm in its 4 ohm. You know, Wheatstone bridge has 4 ohm, like this, like this. Wheatstone bridge has 4 ohms. You also know that if this is, let's suppose R1, this is, let's suppose R2, this is R3, and this is R4. If R1 upon R2 is equals to R3 upon R4, then we call it as a balanced Wheatstone bridge, and there will be no current in the middle wire. There is no use of middle wire. So you can also replace it by this way. I am giving you like little bit explanation to it so that your concepts gets good. This becomes your R1, this is your R2, this is your R3, this is your R4. Don't go over my writing, you just need to listen to me and understand the concept. It's a simple series, it's a series parallel, you can damn solve it. Okay, now moving to the question, our original question. What resistance joined to 30 ohm it will bring it to balance condition? Okay, it is asking that what resistance should we join to 30th ohm? It's like there is a 30th ohm resistance. What resistance should we join? Like let's suppose we add X resistance so that the condition got balanced. Okay. Like let's suppose here we have a fourth resistance which is we call as a 30th ohm. So what we can do? Like we can attach a resistor to it and parallel to it, and thereafter we can use the balance condition and we can solve it out. Okay, now moving to the explanation, as we have to decrease the resistance, so the equivalent resistance of 30th ohm arm after attaching a parallel resistance across it must be of 10 ohm so that the grid becomes balanced. So we have the attached parallel condition to this. Okay, do one thing. Like first we need to check whether the arms like condition is balanced or not. So R1 will use, let's suppose R1 will use 10 ohm, R2 will use 10 ohm, R3 will be your 10 ohm, and your R4 will be your 30 ohm. Now putting the balance condition, R1 by R2 is equals to 1, but R3 by R4 will is equals to 1 by 3. So you can see that it is not in the balance condition. So we need to put in balance condition. As you know that here R1 by R2 is 1, but R2 by R3 is less than the 1. Okay. So we need to attach something to R1, or like what we can say R4, any one of them, so that it can increase the equivalent of it. Okay, so we should attach the like parallel resistance R to this combination. So there will be three parallel things like 1 by 30th, 1 by R is equals to 1 by 10. Why we are trying to do this actually? Because we know what equivalent do we want. Like understand in this way, it's a little bit tricky question, you need to understand it out. First is to understand that R3 is your 10 ohm, okay, and R4 is your simply what 30th ohm. So you need to decrease the R4 to, so that equivalent will become 10. You're getting me, because we want the ratio 1. So to get the ratio 1, we want to decrease the R4 to get it like what? To get it to 10, so that the ratio becomes 1. And another thing, you can do one thing, okay, you can add to R3 to get 30. But listen, question is saying what we need to change to R4. So it is constrained that we have to change R4. So we can't change any other. Now tell me, if you need to change R4, which is 30 ohm here, so what you should do? Like you need to decrease it to 10. You know, when you want to decrease the resistance of any resistor, you need to attach resistance parallel to it so that its resist equivalent got decreased. First thing. Another thing is that you also know this. We want an equivalent of 10. Because of 10, the ratio will become 1. So this is the equation which is written here. We want the equivalent 10 and we want to do change in 30, and we are attaching a parallel resistor of R resistor, because parallel will decrease 30. You know that when we attach something in the parallel to a resistor, it will decrease the equivalent resistance. So you can understand from the even the option without solving it, because it is not asking about the value of the resistor, but it can ask in another examination or in a future examination. So you should also know to solve it. But at least for this question, we get to know that we should add, okay, resistance in parallel. So this option will just got cancelled. But yeah, there the value is asked, so you need to solve it out. Now solving it out, 1 by R1, 1 by R1, 1 by R1 plus 1 by like R equals to 1 by, we should write it as a 1 by R4, we should write it as a 1 by R3, or whatever it is. You know it is 30, this value, you know you need to calculate this value, you know this is 10, we want R equivalent. Okay, so by solving it out, we get R equivalent is equals to 50 ohm. 15 ohm, that is option of first is your correct answer. Moving to your like second question, here it is mentioned like option second is mentioned wrong. Okay, just understand the concept. I always told you, honestly, go with the concepts, don't just mug up the things. Now moving ahead, a compartment of a train is lit by 20 identical bulbs in series. Okay. One of the bulbs fused and is removed from the chain. The remaining bulbs now light the room. The light in the compartment will. What will it? Basically, you need to understand like there are 20 identical bulbs. Identical means what? The resistance are same for it. You know that the resistance are same for it. Now, if in series they are like one ball fuse, okay, and removed from the chain. It is removed. It doesn't say that we cut the wire from there so that no electricity will can go through it, and there no bulb will glow. It is saying that the bulb is glowing. That means that suppose 10 bulbs are connected in a series. One bulb gets bad. We just remove that bulb, but we don't break this circuit is still complete. Now it is asking the light in the compartment will what? What happened to it? It is asking about the light in the compartment will be. Now moving to the like explanation. Okay. Suppose that a single bulb has resistance R and supply of each bulb is V volt, because as in series, so what? The like the potential along different bulb is like different. Okay, but as here the current is same and the resistance is same, so potential will be same for each. So for each it's V volt. In case one, the equivalent resistance of 30 such bulb, it's not like 30, it's 20. So it will be generally 20 R. Okay, as mentioned in the question. Now we can calculate the power. We know like their bulbs are in series, so we can calculate the power. Power can be calculated. We know we consider the voltage. We can consider the current also, but we consider the voltage. So power is V square by R. So power will be your V square bar is 30th R. Like R equivalent here, we should write it. Power equivalent here, we should write it. In case two, what happens? The one ball got disconnected, so we don't have that resistance. Okay, the non-resistance become 19 R. Okay, now the power becomes V square upon 19 R. Again, the voltage will remain same. Understand this, because in series each has a different voltage. Okay, it has a different voltage, and voltage depends on the proportion of current and and resistance. As the resistance remains the same, so the voltage drop across each is same. You need to understand this. As the resistance remains the same, so voltage drop across each resistance will remain the same. What will happen in this case? For the power next case, the P equivalent will be your V square by R equivalent. That will be a 29 R. Means P2 should be greater than equals to, sorry, not equals to, P2 should be greater than P1. Understand one thing, like you can think in this question in another way. This is the solution to it. Okay, but you have some questions in mind, like if we have 20 identical balls of series and one ball get fused, so what will happen to other ball? You know, you should understand this. Like if one ball gets fused, okay, there is two conditions. The all balls will not glow then. Okay, because as one ball gets fused, the circuit will get break and there will be no pass of current and the bulb will not, other bulbs will also not glow. But in this question, it is saying that the bulb is removed. Means that the circuit, they corrected the circuits, make it correct and remove the bulb. And now asking about the light in the compartment. What our common sense will tell you? Our common sense will tell you, suppose there are 20 bulbs in this room. And if you remove one bulb, what the light change in the light will be in this room? You will say that it will decrease. But if you have a little bit of physics or scientific mind, you will ask the question whether we should not ask this, that the bulb is in series or is in like parallel. Does it affect the light in the compartment? Yeah, it actually affects. If that 220 bulbs are connected in parallel, there will be a different scenario over there. Okay. And if they are connected in the series, then there will be a different scenario. So you can't be so sure that the always there will be decrease in the light. No, no. It depends how the bulbs are arranged. As we did the calculation, I am just making your confusions clear. Okay, so that you should not be confused that I have this question in my mind, sir. What's the answer of this question? I'm just clearing on confusion. Your basic confusion is that suppose there's a room like this and one bulb is removed, so the light will should decrease, but not. It will not happen always. Okay, because the combination of that bulb is an important thing here. You should take care of it. I hope you got the answer to it. And any confusion, you can just comment me out. So the answer, according to the calculation that we got here, is that like it should what increase as the power increases. As the power what get it just increases. Moving to the next question. It is saying that a wire of length L and resistance 100 ohm is divided into 10 equal parts. Okay, the 5 parts are connecting in series while the next 5 are connecting in parallel. The two combinations are again connected in series. The resistance of the final combination is, like it's divided into 5. So if the length is L and resistance is 100 ohm, is divided into 10 equal parts. Okay, if it is divided into 10 equal parts, then resistance of each part will be what? 10 ohm. You got that? Resistance is directly proportional to L if the area and other things remains constant. You got that now. So if resistance is directly proportional to L. If it decreases the length, resistance will linearly decrease. So if it is divided into 10 parts, then the resistance will become 10 ohm for each of the parts of the wire. So we have 10 equal parts of the wire. 5 parts are connected in series and other 5s are connected in the parallel. Okay. So the thing which is connected in the series has the resistance of what? 5 plus 5 plus 5, sorry, 10 plus 10 plus 10 plus 10, up to 550, it's simple. And which is connected in parallel will be 10 upon 5 is 2 ohm. Then connected in series, what? 50 plus 2 is becomes 52. So we can just solve it by mind. It's become 52. Like option 4 is the pure correct answer. Okay. You can see the explanation here. I have explained you verbally. It's a easy one. Now moving to ahead, the potential difference it is asking. Okay, it is asking the potential difference. So you said just need to use Kirchhoff's law. It's a simple question. Okay, you can use it like VP. If you just take this direction, like voltage is dropping, or like it's a positive, it's negative. Like current is flowing from the positive to negative terminal. It's positive, negative. It's again positive, negative. That is it's Q. So VP plus 3 into 1 plus 2 plus 2 into 3 plus 1 equals to VQ. So VP plus 3 plus 2, 5, 5 plus 6, 11 plus 1, 12. It will be minus 12 volt. So option 3 will be your correct answer. It is asking VP, and then what it will be? It will be like 3 ohm plus 2 ohm plus it is a 6 ohm to 10 to 12 is equals to VQ. So it is asking VP minus VQ between the points in the part of circuit. So VP minus VQ, it will be equals to minus 12 volt. It will be equal to what? Minus 12 volt. Because as the current, if you have a sign convention, so let me explain it here. Like if suppose there is a resistor and there is a battery, and if the direction of current is shown in this direction, that means current always moves from the higher potential to the lower potential. It will be in higher potential to the lower potential. Okay, you can just understand this in like this way. Like if you are moving in this direction and you are getting plus, so just write it as a plus. And if you are getting it as a plus, just write it as a plus. Okay, so if you do it, it will come out to be VP plus again plus again plus again plus is equals to what? VQ. So it VP minus VQ will be your minus 12 volts. So option 3 will be your correct answer to it. And let me check what they have used here. And like they have taken it negative, negative, and then negative. So actually, if there is a confusion, like it's a little bit of confusion. Like if they take it negative this way, positive, negative. Let me explain it very clearly so that there will be no. Their answers may be wrong. Okay, misprint will be there. Don't worry. Understand this. This is plus. This is minus. Okay. The current is in this direction. Okay, and you go in this way. Let's start from here. Okay, you go like this. Now you find it here like what? It's minus VP. What it will be? Like if you just start from here, it will simply you minus. It's the potential of this will be what? Minus. This is your VQ. Okay, and this is your VP. So minus VP VQ plus VP. It's in the same direction as moving to take it as a positive plus IR, and this is plus again, this is plus. So it will be minus 2 volt, 12 volt actually. It's not correct, like it should be minus 12 volt. You can just make the circuit and also solve it. So correct answer will be option 4. Moving to the next question. With the increase of temperature, the conductivity of metal increases and semiconductor decreases. It's asking about the conductivity. It's again a completely theoretical question. We can understand. Like as we increase the temperature, okay, the resistivity of the conductor like increases. Hence, the conductivity decreases. So the resistance will increase, and the metal in metals conductivity will decrease. But in semiconductor, the conductivity got increased because as we increase the temperature, the holes get more energy and they get more there will be more recombination. So the overall photo currents or like that hole plus the electron currents, semiconductor currents got increased, but not in the case of conductor. Okay. In case of metal conductors, the decrease Semiconductor in a semiconductor it increases, but in metals it decreases. The second option is the correct answer. Now moving ahead, in the given circuit, the switch is closed at t equals to 0. Then the correct statement for the current in the resistance PQ. It is asking about the resistance in PQ. I. It is asking about the I shown in the figure. Now, you should understand this. Okay. The switch is closed and the capacitor is connected. It's a CR circuit. Okay, you should understand this. At t equals to 0, T is as a closed circuit and all the current will flow from it. Okay, understand this. First, you should got to know this, what's happening here. Let's suppose at t equals to 0, when switch gets closed, the capacitor just starts charging. So it will behave as a closed circuit. You know this. And when the capacitor got fully charged, it behaves as an open circuit. So when capacitor behaves as a closed circuit, okay, capacitor behaves as a closed circuit, so the all currents just pass through this wire because current always choose a less resistive path. So it will all pass through it. Got me now? Okay. So you can there is no use of this topic. So you can calculate the current. Current will be what? It's V upon R equivalent. V will be here 20 volt and R equivalent is 1 kilo ohm like 10 to the power 3 ohm. It's simple. You know the current rule. At t equals to 0. Okay. At t equals to 0, the current will be this. Okay. Now, when we increase the what we can say like we can calculate the 20 upon it will be this sorry at t equals 0 it will be this sorry once you do the calculation it will be this. Now when time will increase, capacitor got charge, it will have a capacitive resistance. The current will got decrease. So we can talk at infinity. At infinity what will happen? Capacitor behaves as an open socket. Just make it open. Just as you make it open, there is no use of it. Now the current will go in this way. Now the total resistance becomes 2 kilo ohm. Now the current decreases. So as t equal to 0, the current is this, but as t goes far away, it decreases. Then option third is the correct answer. It's a simple CR question. It's a simple question. You just need to understand how to deal with the capacitive circuits. Okay, it's so simple. Capacitors have just one concept. At t equals to 0, you just make it behave as in closed circuit. Okay, like this. And at t equals to infinity, just make it behave as an open circuit. In closed circuit, this had no resistance, current will directly pass through it. Open circuit, it there is no use of that capacitor or that wire. It's simple. Now moving ahead, for which of the following independency of drift velocity on electric field? It's again a very theoretical question. You know drift velocity. Your drift velocity will be what? Velocity is generally what? Acceleration into time. Okay. Acceleration in the case of what? Acceleration is force upon mass. Force upon mass is torque. It's simple. It's directly proportional. You can give it a one shot answer. Now moving ahead to the next question. You can see the explanation. You can get the PDF in the app. You can see over there. AB is a wire of uniform resistance. The galvanometer shows no current when the length of AC is 40 centimeter and CB is of 60. That means total is 100 centimeter. It's 1 meter. The resistance of R is again a balanced Wheatstone-based condition. If you have read the galvanometer and like formulation and all, you can do this question in one like click. You just need to the balance condition. Okay, length balance condition. You know total length is 100 centimeters. It's so simple. You just need to this R of this to the R of this to the length of to the length of this. It's so simple. R of 75 is equals to L upon 100 minus L. You got that now, like L upon 100 minus L. Just solve it out. and find that and get your marks. If R is equals to 50, like it's of second option is a correct answer. Now moving ahead to our next question. Okay, it is asking which of the following IV graphs. It is a characteristic IV characteristic graph represent the omics. Oh, it's a damn theoretical question. You know, like it's what you know, like V equals to IR. Okay, so I equals to what? I equals to V upon R. So I equals to 1 upon R into V. So it's the slope. It's a straight line. So option first is directly cut. But you need to learn the slope. The slope is not R. The slope is 1 upon R. Remember, it is IV characteristics, not VI characteristics. Moving ahead. Now it is asking two resistors of resistance 100 ohm and 200 ohm are connected in parallel. So they are connected in parallel in an electric circuit. The ratio of the thermal energy developed in the 100 ohm and that of to the 200 ohm. Okay. You need to calculate the ratio of the thermal energy. You know how the thermal energy is given. Thermal energy is directly given using the, you can give it, like, there is no issue of time. So you can also say it as a, we need the ratio of power because there is no issue of time. The time got cancelled. So even if you calculate the ratio of power, the answer remains same. Even if you calculate just the ratio of the heat energy, it remains the same. You know, that if they are in parallel, both will have the same potential. Let's suppose their potential is V. I'm trying to understand the concept. Now you can calculate current through, and if both have the same potential, you can calculate the, what can I say, power of each. You know, power is equals to what? V square upon R. For one, it will be 100. For another, it will be 200. Take the ratio, it will just become out to be 1. If we just, what is asking? To that of 200. Okay, like P1 will be what you V square by 100 and P2 will be what you V square by 200. Thermal develop in 100 ratio to that of 200. Is 100 ratio to that of 200 means like what? P1 by P2. P1 by P2 will become 2 ratio 1. So second option is your correct answer. I hope you got it. Now, the next question. A wire of resistance 10 ohm is stretched to twice of its original length than the resistance of the half of the stretched wire. Okay. Remember, it is not asking the full resistance of the wire. First, you need to calculate the resistance of the new wire. Then you need to calculate the resistance of the half of the length of the new wire. Understand this. So if a wire has 10 ohm resistance and it is stretched twice of its length, you know that like the volume remains constant and hence area got decreased. Length get twice, area got half. So you can calculate the new resistance simply by using what? Simply by using R equals to rho L by A. Rho is same for whole procedure. That is, so your R2 is like your new resistance can easily be calculated. So your new resistance will come out to be something like what I can say it's of 40 ohm. Now you need to calculate the half of it. So just cover it out. 40 by 2 will be your 20. The second option is the correct answer. Now moving ahead. Six similar bulbs are connected as shown in the figure DC source of EMF. Okay. And zero internal. It's the same zero internal resistor. Ratio of the power consumption by the bulb when all are glowing and in situation 2 from section A and 1 from section B is not glowing. Oh, it's a nice question. Little bit of. Okay. If all bulbs are glowing, understand it. As all are in parallel, as all are in parallel, so potential along all are will be the same. So you can calculate the R equivalent. You got it now. Like you can easily calculate the R equivalent. How you can calculate the R equivalent? These are in parallel. These are in parallel. Then they are in series. R by 3, R by 3. So your R equivalent will be 2 R by 3. It's simple. 2r by 3. And now you know the EMF. Now you can easily calculate the power. It's simple, this power. Now 2 from section A, like 2 are gone, 1 from 3. Let's suppose there are only 1 and there is 2. This circuit becomes in this way. Got it now? It's E. It's R, it's R, it's R. Now what to do? It's simple. R equivalent, just made it. Now your resistance will become this, power will become this. You can take the ratio, it will become out to be 9:4. It's a simple conceptual question, don't worry. Second option is the correct answer. Now moving ahead to the next question. Again, there is a capacitor, there is I think it's again the same question. Two resistor of this, capacitance of this, ideally of this, which is closed. Okay. The initial current and the current in steady state, you know, at t equals to infinity is called a steady state. You should know this. These are simple concepts. In physics, you need to only understand the basics of the concept. If you just do a little bit of practice in a conceptual way, you can't crack the like you can correct the crack the question. Make me pardon that. It's a simple question. At t equals to 0, no use of this. Make it as a simple wire. And you can calculate the current. At t equals to infinity, no use of this. Make this as a simple wire. Then that you can easily calculate it like current. So by solving it out, you get this answer. No issue in that. Its answer will be your 1 ohm and 0.2. Means like what third option is the correct answer. You can check the calculation and get PDF from the app. No issue to that. I'm just concerned about your concepts and understanding behind it. Now, when the current flows through the copper wire, the current density, J is equals to sigma I. You should remember this relation. It's the vector relation of, what can I say, Ohm's law. It is called the vector relation of Ohm's law. Where motion of electrons have in the direction such that when the current flows in a copper wire, current density and electric field, the motion of electrons have direction such that, okay, when we just put the current, electric field, the electron has the tendency to what? Flow the opposite direction to that of what? The opposite direction to that of the field, actually. So actually the current is moving in opposite direction. As the current is moving in opposite direction, hence the current density. Okay. So we should understand this. So means what? The direction of actually, if we just go through the convention, then we know that the direction of current is the motion of positive charges, and whatever be the direction of the current will be the direction of the current density. As positive charges is moving along the what? Positive charge do not move actually. This is the thing. Positive charge do not move actually. Okay. So there will be, it is asking about the current density and electric field. It will be in same direction actually. It will be in same direction. But the current, because the current density has that direction which has of the electric field. You should understand it. Okay. You can also understand with this relation. Current density will be in the direction in which there is electric field. But it is opposite to that of electron. Because I am explaining that much because they can twist the question. They can ask you the direction of electron also. Here it is not asked, but you should know this now. So option 4 will be your correct answer. It is wrongly mentioned here. You should understand it. We can prove it out. By this relation, it is proved that sigma is your current. Sigma is your simply it represents your current density. Its electric field represents your this what electric field, and this is conductivity, because the conductivity is resistivity, opposite reciprocal of resistivity, so it represents your conductivity. So current density is proportional to the electric field, so both will be in same direction. It is asking what The motion of electron. Okay, okay, okay. Sorry. I gave you extra knowledge. It can be used in future. But here in the question, it is asking the motion of electron with respect to J and E. It will be in the opposite direction now because J and E is in the same direction. An electron moves opposite to the current. So it will be in opposite direction to that of J and E. So correct answer will be option number A. Sorry. It's correct. But I have gave you extra knowledge. You should remember it. The point is that now you should learn the physics to think. Don't need to remember the things too much. Basics and fundamental things to be remembered. Otherwise, you can't solve in the examination. You don't have that much time in the examination. Now, two cells A and B of EMF 4 volt and 2 volt, with each with 5 ohm each. Okay, each is saying here. Are connected shown in the figure. It's okay. Potential difference across the difference VA across the terminal cell A. Okay, it is asking the potential difference across. You just need to use the Kirchhoff's law and nothing else. As you know that the circuit is in this way, like, so both are opposing each other actually. So there will be negative E1 minus E2 will be there. So E net will be E1 minus E2. You get E net, you get R net, you can get electric current, and once you get the current, you can calculate the drop. It's simple because you know V is equals to what? E minus IR. Simple. You know E, you know I, you know R in internal resistance. If you put A, it will be A, it will be A, it will be A. Simple. Just do the calculation. It will be 3.5 volt. Option third will be your correct answer. It's a simple Kirchhoff law test. Moving to the next question. A copper wire of length 10 meter and radius this electric resistance. This is the current density in the wire of electric field of this. It's again a simple question. You know J is equals to sigma E. You know sigma is equals to 1 by resistivity. You know resistivity equals to what? R equals to what? Rho L by A. So you know rho is equals to RA by L. Just calculate rho, put rho here, put electric field here, you get J. This simple formula is. Just do the calculation. Sorry. Do the calculation and you get J is equals to this value, which is your 10 to the power of 5. Means option number 4 is the correct answer. Now moving ahead, in the circuit shown below, what will be the reading of the voltmeter? Again, is a potentiometer type understanding. If you have little bit, you can easily solve it out. Let me check. It is a capacitor. It is an in. Okay, it's a LCR circuit question. It's simple. Don't worry. You know that a V net is equals to what? It's simply your under root of VR square plus VL minus VC whole square. It's simple. You know Excel, you know Z, everything you know conceptually. Okay. Now it is asking that the reading of the voltmeter and the data of the ammeter. Okay. So voltmeter will be connected across the your across what? Across your resistor. Here is the voltmeter that is across the resistor. An ammeter is for the circuit, the current through, which will be calculated using resistor. Simple. If it is a resistive circuit, okay, and as you can see, it is a resistive circuit because the potential drop across the inductor and the capacitor is same, so the difference will become zero, and hence the whole circuit becomes resistive. And as the whole circuit becomes resistive, that's very simple for you. It's simply like that. Like you have ammeter here, you have potentiometer here. You just need to tell do these two values. Simple. Just you know the R, you know the two V. You can I, you can V the potential. It's simple. You know I is this, V is this. 222.8. Option number 4 will be your correct answer. Now moving ahead. The VI characteristics of the non-linear device is shown in the figure. The region is we show negative resistance. Negative, you know that V equals to what? IR. So V equals to R is your like slope I. So slope is negative, it is negative. It simply you can see in PC region. Here the slope is negative. Here slope is positive. Here slope is positive. Only here the slope is negative. BC is the correct answer. Theoretical question. Don't need to worry too much. Now, the next question. The charge Q flowing through the resistances vary with time given in the total heat produced. Okay. You need to understand that resistance is given. If heat is equals to generally what? I square R T. Okay. Time time is not given here. Okay, let me check it. Check it out. So what will be like this? Mm, I can be calculated as a dq by dt. It's simple. When you do the calculation, it will become this. Now you know, like you can calculate like heat produced is varies with time. Our current varies with time in this way. There is a conceptual catch here. It's a good question, I think, because time is not given directly. Okay, it's like let's suppose you need to understand. Okay, you know that to calculate the amount of heat produced, you need to understand for how much time the heat like current flows through. If the current flows through just for 2 seconds, you just need to calculate the heat produced in 2 seconds. If the time is not mentioned anywhere, okay, then you should understand in this way, like up to what time the heat can produce. You got a simple and direct answer. It can happen till there will be flow of current. So put the current zero and get the time, and then you can do integration and find out this. Because time finding the time is the issue here. Okay. So dH will be what you is I square R dt. Now you know the integration from 0 to 1. Just fill it. If you just do the calculation, it will become out to be 40 by 3. And R value is given. Just solve it out and get the answer. The catch is important. It's a good question. I will make out as a good, good question. Not direct question. You need to understand that how to calculate time here. Now moving to it. The current flowing through the ideal ammeter. Okay, it is asking about the current flow. Oh, acha. Okay. It's you need to first solve this circuit. Okay, like you need to solve this circuit first. Understand in this way. If you just do one thing, like what? Just use the potential concept here. Don't worry. I suppose there is a V, there is a zero, there is a V, there is a V, there is a V, there is a zero, there is a zero, there is zero, there is X. There is a V, X, and zero. Between V and X, there is two resistors. Between V and zero, there is one resistor, and there is another resistor. And between X and zero, there is two resistors. It's simple. Just I have just used the potential concept. Now these two are in parallel, these two are in parallel, these two are in parallel, then these two are in series, and then they are in parallel. It's damn simple, don't worry. It is the mentioned here in simplified form. So these two are parallel, these two are parallel, then they are series, then all three are in parallel. As similar here, these two are parallel, these two are parallel, then they are in series, then all three are in parallel. It's simple, don't worry. I have just given you a method to solve it. Just consider V0 here. All give each terminal their potential and make like a wheatstone based thing, and you can easily solve it out. You know the current, you can calculate the current easily now. R equivalent you just need to know, and then you can calculate the current is 2 ampere. You can see the calculation. I'm more worried about the concepts. Now moving ahead. Is it possible that any battery has some constant non-zero value of mu, but the potential difference in the plate is zero? Okay. Is it possible that any battery, it is talking about the battery, has some constant non-zero EMF, like it has EMF, but the potential difference between the plates is zero. Potential difference, it is telling that it is zero. Okay, it is asking about the plates. Yeah, exactly. Like it's asking about plates. So suppose if you connected the battery in this way, then it will be possible. You can get E minus E equals to zero between the plates. You've got cancel out. Yeah, it is possible if opposite direction. If the current is sending in opposite direction, then it is possible. If they both are supporting, then it will add up. You know the series, you know now when we attach the cells in series and attach in the parallel. So similar is acts in different way. Now moving ahead. Which of the following acts as a circuit protection device? I think it's O should be like this. Yeah, so don't worry. Use generally act as a circuit protector. It's a theoretical question, and I think it's 80% of no use to us because switch is not protection. Conductor never protects the circuit. Inductor is also type of conductor. Okay, asking again VA. You just need to use the. You just need to understand the use the Kirchhoff's law. You should understand and know how to use the Kirchhoff's law for it. So understand one thing. Okay, don't get confused in using the KVL or KCL. Every different person have different way to solve the KVL equation or KCL equation, but the fundamental remains the same. If I am taking some convention as a positive and some as a negative, I should stick to this to the whole calculation. Okay, the final answer should be the same. Okay, if it is not done wrongly, then only. But if some people is doing in different way, they should take care of all this to the whole. Okay, so this is the thing. So you should know, understand to use the KVL. First, just write it like this: plus, minus, then plus, minus, and fix the direction of current. Like when we are moving in direction of current, if you have remember, like you can take in any way. You can take it as a positive, take it as a negative, but be stick to one convention to the whole question. Don't change in between, otherwise you will look it wrong. So my way of doing it is little bit different. Okay, like I took the current, like let's suppose there's a plus sign, the potential. Let's suppose it is 12 volt. Let's suppose we took the current in this direction. Let's suppose I current flows in this direction. Let me draw it from here. Yeah, you can get it here. I current goes this way. I goes this way. Here it is, let's suppose I1, and here it becomes I minus I1. Now again it's I1 and here it is I. Now if we use KCL, KCL tells what? Summation of I in at any junction is 0. Is what? Simple, you know that I is equals to what? I1 plus, if you just take it as I2, it's I2. Simple this KCL. Now if we apply the KVL, okay, you can just start from here, tell it here. Just as the current is moving, current goes from higher to lower. You can just take at a, if you are moving now, if you're touching a cell, if it is in positive terminal, take positive. If you're touching a resistor, if it is in positive terminal, take it as a positive. There is no issue with that. Okay. Simply you can use the KVL here and find the answer. As it's a long calculation, you can do it by your own self, simply using KVL and all, and you got the answer. And the answer is 6 volt. You can do the calculation. I have make you understand the like concept. Yeah, in this cases, calculations are needed. You should do it. Otherwise, in exam, you will definitely make mistake. Yeah. The current density across the cross-sectional area this is this. The current flowing through this, J is equals to what? I by A. So you know I is equals to j dot a. Just take the dot product. It's simple. Because both are vector. Current density and area vector. You will get the answer 8 micro. The reading of ammeter in the circuit shown in the figure. It is again damn simple question. Yeah, you can just do it. Calculate the R equivalent. It will be all are in parallel. Take R equivalent. That will be total current. Now, if you know there is total current, then you can use the formula like this. Means like you know this is total. You know potential will be same for each. So you can just calculate the current in this circuit. Simple question. And once you calculate it out, it will 1.5 ampere. Thus, first calculate R equivalent. Then this all are parallel. You get R equivalent. From R equivalent, get I equivalent. You know potential will be 12 ohm here. You know current here. You know current here. You know current total here. Now you can just minus minus and then left current will be in this circuit. It's simple question. It's a question asked in 2024. I can remember it. This is again a basic question. Terminal voltage in a battery is 10 volt. EMF is this 1 ohm. External. So you just need to V equals to E minus IR. E you know is 10 volt. I you just need to calculate by V by R. V equals to I can be equals to E by R equivalent. You know R. Just calculate the V. It will 8 volt. I can remember the answer of this question. Basically. Now moving ahead. Electric bulb of this glow at full potential used in parallel with a battery of this. Battery of this and okay, it's a EMF, it's a internal resistance. Maximum number of balls that can be connected so that they glow in full power. Okay, it's a good question actually. Let me tell you, it's a good question. It's a new type of question. The new means what? You have read it, but it's some people got confused in this. Now understand it. We what we want? We want to glow the bulb full power. And the power is also mentioned, the range of power actually. It's 50 watt to 100 watt. Okay. And we know the battery, so 120 and 10 ohm. Okay. Now, okay, here the voltage demands means that there is one bulb. Okay. The voltage of that bulb is 50 watt and volt along it is now. You can calculate the current through it. It's simple, and you know the battery thing. You can also calculate the you know the current through the bulb. Okay, you know the current through the bulb. Now think in this way. Okay, like let me explain you. Suppose there is a bulb like this. There is another bulb like this, and there is an N bulb, and there is a battery. That battery has a voltage to 120 volt, internal resistance 10 ohm. So you know the EMF, you know the volt, like okay, terminal voltage. Yeah, you know the terminal voltage as it is in parallel. So terminal voltage across this will be here also. So you know terminal voltage. Now next thing, you don't know the actually the current, but you know R. Current will be what? Let's suppose the maximum of bulb that can be connected. If you ask me maximum number of bulb, now understand it. If through one it is going 1 by 2 ampere current, here also 1 by 2, here also 1 by 2. Every time one, let's suppose there are n bulbs. What is the main current that coming out from here? That must be n by 2. Then only now they can distribute n by 2 in n will be 1 by 2, 1 by 2. Let's suppose I have 10 mangoes and I have 10 people. Then only I can, each people can get one mango now. In a similar way, if I have to give half mango to each people and there are 10 people, then how much mango I should have? It should have 5 mango. Similarly, if there are half current going through it and we have n bulbs, so how much we should need in total? It should be n by 2. So you know the main current, that is N by 2. From here you're going to the N, that is 4. It's a good question also. A little bit confusing, that's why I called it good. It's not direct. Okay. Now moving ahead. Two bulbs of rated power 60 volt and 100 volt. Same specified, sorry, voltage of this. Okay. Voltage is same for both. Connected in series, okay. And DC voltage is given to the source. It's source voltage, it's this source voltage. You know the current? Current is same. What it is asking? Okay, it is asking about the brightness. Okay. Okay. You can calculate the current through it. If more current will pass through any of the bulb, it will get fused. It's again simple question, yeah. You have bulb one, you have bulb two. For bulb one, you know potential, you know power. For bulb two, you know potential, you know power. So hence you know the current through bulb one, hence you know the current through bulb two. If current in any one is greater than the required, it will just fuse out. You just need to do calculation, yeah. Which means like as you can see that they have done the things here, and now which means more power bulb B and hence it will go brightly. Also they have compared it. It means like no bulb will fuse. First you need to understand which bulb will fuse or not. If no bulb will fuse, then you need to calculate which bulb will have more power. So how can you calculate which bulb has more power? You can calculate it by using P equals to V square by R. Simple. You know voltage of each, you know power of each, you can calculate the resistor of each, and by using resistor, whose resistor will be higher, their power will be less. As you can see, the RA is greater than RB, that means PB is greater than PA. So simply, the bulb B will glow more. Bulb B will be what? So what? Option second is the correct answer. Now moving ahead, in the circuit shown, the reading of ammeter when only S1 is closed. Okay. I2 when only. Acha, there are three settings. Okay. One, S1 is closed one time, another time S2 is closed, third time both are closed. If S1 is closed, there is no use of this circuit, just take it as this as a circuit. When S2 is closed, no use of this circuit, take this as a circuit. When S both are closed, then these two are parallel, then these, then again. You can easily calculate. It's a very damn easy question. You just need to calculate current in each case. Unit for calculation is V upon R equivalent. Just treat one by one circuit. Don't do it at once. Treat it as one by one. Okay, treat it as one by one. It's a simple question. You can know, we can put I1, I2, and then I3, and you can understand that I3 greater than I2 greater than I1 means option number third is correct. Now moving ahead, a bulb power is given, volt is given, source voltage is given. It's again a simple question. It's asking about the resistance of the heating coil. You know power. Power is equals to what? V square by R. You can calculate the resistor of the bulb. Now what? Simple. That resistance of the bulb will be a heating coil. There is no use of this. As this both are same, so there is also no use of it. It will be simply option first is the correct answer. Resistance of the forearm. Okay, given which number is okay. EMF is given. Internal resistance given is 2.5. Remember it is 2.5 ohm. The galvanometer is my okay. Then the net current drawn from the cell. Okay, there is no use of this. It will balance condition. You know, it's 10 upon 20 equals to 30 upon 60. Both are equal. 1 upon 2. To balance condition, no current will be there. You can calculate the current total thing. It's become a simple circuit. It's again a damn simple question. Damn simple question. You know everything. You know everything here. You know everything. Just calculate the I total. Simple. Similar has been done here. You can see the PDF in the group. Okay. What's the answer? What is the question number 32 now? The answer is 0.6 ohm. You can calculate it. Again, I am focused about your reasoning and your concepts. Two heaters A and B have the power rating this and this. Power is don't take as a heater. Don't heat your mind looking at a heater. Just take it as an appliance and resistor. Power is given, just take it. The two first resistors, the two resistors are connected in series first. Then both are connected in series, sorry, parallel. Okay, it's damn simple. It is asking about the ratio of the power outputs in the two cases. Remember, like if both the heaters are, let's suppose, are connected in series, what will be your power? What will be your net power? Tell me. What will be your net power? When the power is exactly in series, you can easily calculate it out. See what will be your net power through it. Simple. As you can see, like for both the cases, what will be like the resistors are simply, let me check once again. Two heaters, okay. There are different resistors have same have ratings of 1 kilowatt, and those two are collected in three fixed power source. Okay, okay, okay. Remember this. This is one, this is another, and it is connected with V volt. Or let's suppose it has a resistor RA, it has a resistor RB. The whole is V. Okay. Now tell me one thing. The current through these two is same. Okay. So power of A is equals to I square RA. Power of B is equals to I square RB. So PA by PB equals to I square R. It is wrongly done here. Just take it this way. So PA by PB got the relation RA by RB. Okay. Now you can control the ratio of the power outputs also in different cases. Now if they are in parallel, the voltage will be same. You use this equation. Then again take it is reciprocal of it. Just you need to use it. First you know the relation between this RA is of this part. Now you can consider the power in series combination. Power is equals to what? You can simply use in this way now. If in series, then do in this way now. R equivalent. There is a V voltage. R equivalent is your 3 times R. Simple. So your simple will be your V, then it's V square by 3R. Because we need the ratio in PA by PV, means final PA final by PV final. So there's both should be in V. So we first take the use of I to calculate the ratio, then we make it as a series combination, and then we can do in this way also. Like here, I am giving you multiple ways. Yeah, don't just get confused. Understand the situation of how many ways you can do. You can just not learn one way. Okay, you should learn other ways also so that your mind will grow. If you are doing in this way, let's suppose there is circuit series, then both are in series, so you can do in this way. Take it as a R equivalent. Then if you do this way now, it can also be done. There is no issue with that. But I think there is a, let me check. There is one issue will occur. Like you get R equivalent, you don't get. Okay, okay, okay. In the parallel case, you also get the, what do we want? So we want the ratio of the power now of the two resistors. So no. Current thing is right. First, we need to calculate the relation between RA and NB, and it can be only calculated using I square R. But let wait for a minute. It is done for the case of what? Series. If you are using current. If you also do in parallel case, now it will remain the same, because in parallel case V square by RA and again V square by RB. Like if the resistors are in parallel, then things will remain the same. So they have just mentioned one case. I am explaining you both the cases. It doesn't matter whether you use I square R or V square upon R. The ratio will remain the same. So they have used only one thing. And I explain you both the things. In both the series or parallel things, the power ratio will remain the same. There is no use which method you use. It's upon you. So once we got the relation from here, okay, then we can easily calculate the power in each case. First in series case, then in parallel case. And ratio will be 2:9. Option number 3. I am just trying to make things a little bit detailed to you so that if new questions comes now, you don't get confused out of it. In a Wheatstone bridge, if the battery and the galvanometer are interchanged and deflection of galvanometer will, it's again theoretical question because they go listen Wheatstone bridge if the battery and the galvanometer are interchanged and the deflection no because there will no current in the galvanometer in the balance case now so there will no change simple because in the balance condition even if you put the galvanometer there or not it doesn't matter because the galvanometer from the galvanometer there will be no current okay so it's of no use to think on this actually okay moving to the next question. Yeah. A group of six identical cells, each of their centers is joined in series form a loop. Okay, it's forming a loop. The terminal voltage across each cell. Each cell it is asking. Okay, remember the each cell it is asking. The terminal voltage is given by E minus IR. Okay, each cell. And a group of six identical cells. Each of resistance R in series. So total resistance will be what? 6R. Okay. Let's suppose there are six cells. Similar way. Each of R. The total will be what? 6R because we want total equivalent to get the current so that once we get the current you can calculate the terminal voltage across 1 so current can be calculated by what current is equals to E equivalent by R equivalent simple 6 are connected in the 6 way so it's simply 6A otherwise means like all are connected all are supporting currents that's why I'm just adding it the total equivalent 6E and 6R it will be E upon R it will be I simple. Your I will be upon R. Now terminal, let's suppose for one cell, its EMF E, I current this, so its potential, terminal potential will be what? V will be E minus IR, E will be E, I will be E upon R into R. So it will be 0. Terminal voltage is a 0. Option 4 is the correct answer. Now moving to the next section. Which of the following is designed to interrupt the flow of electric circuit in the case of overload circuit? Okay. Circuit breaker is a theoretical question. You should remember the concept. Circuit breakers, fuse, these are the things which is used as a circuit breaker means what? If you have an overflow in the home, appliances will get like damaged. To save the damage, you need to use the circuit breakers. That's called fuse. Fuse is also the answer of this question. It is mentioned. Moving ahead, point out the right side of the Kirchhoff's junction rule based on the conservation of charge. Junction rule outgoing charge current add ups and equals to incoming current. No. Johnson rule it is asking. Bending or reorienting the wire doesn't change the valid procedure. Yeah, all are then all are correct because it's like Johnson rule is also same. Like this is also saying the same. Like if the let's suppose wire is this current is coming, so you can do one thing. Okay, you can take incoming current positive, leaving current negative. The sum will be zero at the junction. Or you can do one thing negative as a coming incoming current outgoing positive again the sum will be zero at the junction so junction there is no change it doesn't matter so all the options are correct so you don't need to worry if each side of a regular polygon of n side has a resistance this equivalent resistance okay it's a very famous question actually this is the polygon actually so it is asking about the equivalent resistance okay you need to understand it out it's like it's written this in one way. What we can do here? Like each side of a regular polygon of n side. Okay. Like there is an n side of like of it. Now, there is a catch in the question. I don't like answers. Okay, actually, when I look at the answers now, mostly I get more confused. So I want to think by my own self. Between any two adjacent vertices, okay, this is a damn good thing. Like let's suppose we have a like what is this? 1, 2, 3, 4, 5, 6. Hexagon. Not two adjacent. So we have this potential A or B. Now, if you take as this is R, this is R. If it is true for N, it should be true for 4 also, 6 also. So we are doing it in a simple version. So think in this way. These all you can take in series and this in. Let's suppose R, R, and R. So all 1, 2, 3, 5 in 5R. Now it can be converted into 5R and then R. Damn good. So that means one resistor is always parallel to the equivalent of the rest of the resistors. So our circuit will become in this way. R and in bottom and minus 1 into. It's as simple as that. And the same is video. Don't worry. I have explained you the reason. That's the thing. You should take care of it. Concept is more important to you. The power dissipated across 8 ohm. The power dissipated across 3 ohm. It's again a very googly question, like very easy question. Just twist softly, nothing else. What is telling, like the power dissipated across 8 ohm, 8 ohm. The power is this. Power is given here. You from power you can calculate the what. Everything, dude. Everything. P equals to what? I square R. You know power, you know R, you can calculate I. Once you calculate the I, you know the potential difference. Once you know the potential difference is same here. You can calculate the total current. You can calculate the I. It's a damn simple question. What is it asking? The power is about 3 ohm. Simply, if you know the current, you can calculate the power dissipated. I have explained the concept. First, you know the power here. From power, you got the current here. By current, you got the potential drop here. The same potential drop will be here. You know the R equivalent here. You know the current equivalent here. The current, you know the resistor. You can calculate the power. What's the use of going to this much of explanation? You can go through it for your better convenience. I have shown you how to do it in just 2 3 seconds. Like 5 seconds is enough, I think. 10 seconds. If you have a practice, I have again if you have practice. We what? Both options is correct. I don't know the calculations whether they may be wrong. I'm not sure about it, but you should understand the concept. If just I started checking each and every calculation, it will take huge time. Huge. Now, the IV characteristic shown in the figure represents, okay, of what it is. Ohmic, it is not ohmic, not ohmic. Insulator, no current. Superconductance, we don't study too much superconductors. It's simply a theoretical question, non-ohmic conductor. Again, we have another question. The equivalent resistance between the point A and P. This is point A and this is point P. Use the potential concept. Take it as a V, take it as a 0. V, 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 V. No, it is 0. I think this is wrongly written here. How can one resistor be connected by the two wire? I think they have put, yeah, wrong answer. Like if I can say now, like if it is not, then there will be no, like it's bullshit actually. Otherwise, okay, you can see. Let me show you. Wait, let me zoom it and show you. Think if if they are, I am explaining you what is the bad thing going here. You should know the bad things so that you can repeat it. Let's suppose it is potential at V and it is at potential 0 volt. Now distribute the potential. It is 0 volt. It is 0 volt. There is no resistance 0 volt. It is 0 volt. It is 0 volt. It is 0 volt. Everything will be 0 volt. There is no way that there is equivalent resistance because between A to B, the potential remains the same, either 0 or either B. So how can there will be any resistance between them? So it's 0. Simple answer is 0. Actually, it's a tricky good question. People will think that how can answer will be 0? But yeah, answer is 0 here. Let me zoom out. Going next, in the circuit shown, the readings of the voltmeter. Again, it's an easy question. You know everything, my dear friend. You know volt, you know resistor. You can calculate the current through it. Once you know the current through it, there in the case V 10 volts is of the same will be here. You know the voltage here. In this case, though parallel, you first need to calculate the current, then current. You know the total current, you know the total resistor, you just know the total potential drop, but it is not asking total, it is asking about only this branch. So just calculate the current. I1 is equals to what? You know, I I1 is equals to what? R R2 by R1 plus R1 R2 into I. This is a formula. I don't remember usually formula. I remember this, but yeah, you can do it by using simple Kirchhoff's law. Just expand the things and do the things. It's very easy. You can calculate it out. And the answer will be, I think both are same. Option A is correct. You can do the, I have shown you the way to do it. Okay, now this is the question. Bulb B1, B2, B3 are three identical bulbs correctly shown in the figure. When all the three bulbs glows, currently recorded by the emitter. Okay, this is the whole emitter. When all bulb glows, how much power dissipated in the circuit when three bulbs glow? It's asking about the power dissipated. As you know, all bulbs are connected in parallel. So you can just do one thing. We say you just need to calculate the R equivalent for each. You know, total current is 3 ohm. Total potential is given here. You just need to understand that identical bulbs, so you can know the R resistance is same for everyone. So it's simple. You can just calculate the you know the current, total current. You know the total voltage. You know the R equivalent because R, bro, R equivalent means what? V equivalent, Y equivalent. You know V equivalent, you know I equivalent, you get R equivalent. Now R equivalent here all are in series parallel. R equivalent will be upon what? R upon N. So you know R. R is equals to N upon R equivalent. N is 3. Here R will be simply 3 times R equivalent. Simple. Once you know the R, you can calculate the power of each. Also, no need to calculate the power of each actually. Oh, there we don't need to go that much. Sorry. We just need to calculate R equivalent using I equivalent and V equivalent. Simple. Then we know the power. Power is V square of R. We know V equivalent, we know R equivalent. Simple. We don't need, if we, it is not asked here, then you need to calculate each resistance. If it is asked, it is necessary. So I'm just giving you more things. Believe me, you just do in two steps. You can understand in this way here. They have also, they have did it very small way. Power is equals to V is given, I is given. So they simply calculate the power. So they have did very good way. I love this way. This is a very nice way. I have done. I have explained you a little bit longer. This can be done in more easy way. Two cells unequal enough even into having intersection. Okay. The connectivity. The potential difference across any of the cell cannot be zero. Okay. It will be not zero. The resistance are different. The potential will be zero. Zero to nahi hoga. It will be not zero. Same be it will be not same. It will be not because so each V1 is equals to what? E1 minus I will be same, but R1. So that doesn't mean V1 is equals to V2 because the things are different here. Option first is correct. You can also see from here. See the calculation. You know that the total current I1 plus I2. You know V1. You know V2. Now you can calculate the I. Once you calculate the I, you should calculate the V. Option C is correct. The potential difference across any of the cells cannot be zero. Potential difference will not be there. So you can think logically also, yeah. Like if all the quantities are different, then how can be the potential difference across each will be zero? They are not given in such a permutation combination that it becomes zero now. There will be a condition to get zero. This value should be zero. So to get this value should be zero, its ratio should be negative of each other. But it is not happening here. It is not told here. Like it's called unequal. No chance. Electric conductivity of a typical insulator is this metal while heat conductivity because it's a simple theoretical question. In electric conduction, only free electron takes part thermoplastic lattice and this heat is conductivity is because during electric conductivity because yeah, this is the first is the correct answer. You can read the theory from here. This electric conductivity means degree which is specified material. I don't read this much. Okay, you can read this much. Okay, I just simple know like in electric conductivity I know only the electrons take part, but in what uh, in thermal conductivity what happens actually uh, what happens in thermal because of the thermal energy there will be both lattice vibration and electrons little bit contribute out of it. So what happens now the electric conductivity of the insulator has very tightly bound what tightly bound lattice and hence electrons over there, so they can't easily vibrate. Okay, so this is the reason basically. And for me now, like I think the questions and options are not made with too much synchronization. Actually, it can't be more make more good. Like actually, question is easy. It's simple telling that you know that the electric conductivity of insulator is very less. You know this, but options are designed in very complex way that directly people don't get it. Like directly people don't feel the connection between the question and the option. But yeah, let me check another option. During electric conduction, no free electrons are no negative. During electric conduction, no number of collisions extremely large. Whether during thermal conduction, no will be color. No, sorry, number of collisions small. It is not the answer. Like electric conductivity, collisions are large. It is right, collisions are large, but average out of it is has some value. But in this, average out is zero in insulator, so there is no current, and hence not conductivity. The first is the most appropriate that can be like seen for me. If you consider the mechanism where the ends of the cylinder fiber supply the phase-free charges make up any charge neutralized by electron moving inside the conductor, in that case there will steady electric field circuit. There will be continuous current. There will be continuous rather than a current shortage. What is saying? If you consider the mechanism where the ends of a cylinder are supplied with the fresh charges to make up for another charges neutralized by the electrons moving inside the conductor. Okay. So suppose there is a cylinder actually. It is saying the ends of the cylinder means this is the end. Charge with fresh charges. Two fresh charges are given there. The new charge you are putting the charges from outside to make up for any charges neutralized by electrons moving inside. Means that whatever the electron is moving here, you are neutralizing it by using outside charges. So what will be? There will be a steady current. Exactly. There will be a steady current means what? That the current which is not changing with time. It's a constant current. When it's like little moment of current, you just put the charges. It just got stopped. Again there will be new charges. Again there will be positive. It neutralized. But in between there will be current. So the current remains constant. It's a steady current, not changing with the time. And another thing is like there will be continuous current rather than current for a short period of time. Yeah, there will be continuous current because you are continuously putting the charges. You can read the explanation here. A cylinder current is supplied with fresh charge at the ends compensate for any charge neutral by the moment of the. This implies there will be continuous supply of charge creating continuous current. Exactly. So field necessary to derive the current. Yeah, there will be field. Obviously, there you are giving the. They have explained you the continuous and the steady current actually. You can read from here. Okay, now moving ahead. The resistance of a wire is R naught if it is stretched to n times lower than new resistance. It's again a simple question. You know, if it n time area will be n times less. Now you need to calculate the this thing. Multiply simply R final. You know, it's again a simple. You can also remember it. Like R final will be what? R n square times R naught. You can derive it also. You can remember it. It's a very standard result. If it is stretched to n times, the length is increased into n times n actually. So now our area will be decreased to a by n. So you know r is equals to what? Rho l by l will be nl, and A will be A by n. So overall n will go upside two times. So it will become n square. So simply first option. You can see this big calculation. Okay, you can see this. I have just explained you two lines in two lines. Don't confuse it. It's not. It will be R equivalent. I think here box. So typing just issue. Initially, five resistors. Each of resistors are connected in series to a battery of EMF and an internal resistance R. Okay. These resistors are connected in parallel to the same battery, and the power constraint for the combination of external resistance will become. Okay. It is asking two things. Okay. First, things are connected in series. Okay. And you are asked to calculate, tell the power. Then things are connected in parallel. Okay. Then you are asked to calculate the power and tell them like what's the ratio of it. Now, if it is series, so simply it will be this. Now you can calculate. This is the current, and you can calculate the power. Power is equals to I square by R equivalent. You know I, you know R equivalent, you know power. Power in first case. When connected in parallel, you know again R, that is R equivalent, one by R1. You know again a current according to this R equivalent. Then you can know the like again what it's called power. Power in this case. Now, if you take the ratio of it, it's simply your power consumption in series by power consumption in parallel. That will be 25 times actually. So option number which is correct here. It's a simple calculation thing. I just go to 25 times. Sorry, here it is written 25 times. Second option is correct. First, things are in series. Okay, things are in series. You know R equivalent. You know E equivalent. Okay, EMF is telling here now E equivalent. E is E. So you can calculate I equivalent. From here you can get P equivalent for the first case, that is I square R. Now for the second case, if both all are in parallel, you know what? You can calculate R equivalent. You can calculate I in each case actually, because V is same for everyone. So I will be simply your E by R equivalent, that is this. This I, this is total I. Now I will be different in different things, but you can calculate power by what? V square by R. But V is, remember this, V is can be always V is the potential difference across the terminal. Okay. So internal resistance is given as R. So you need to calculate V, which is P minus IR. So calculate V from here, put here, and you can solve it out. And hence you get the results. You just need to follow the procedure step by step. Don't try to do it at once in mind. Otherwise you will get just messed up with it. Copper wire radius is given, free electrons given, means density is given, drift velocity drift velocity is asked. So Vd is equals to what? Simply you know Vd is equals to I equals to what? I remember in this way, I equals to Vd NEA. It is the density, it is the charge, it is the NEA. NEA is simply your means what? Area of it through the cross section IVD NEA, and VD is the drift velocity, you know the current. Just put the value. VD is equals to I by NEA. So area is simple. You can calculate area pi r square. Just a formula based question. Now moving ahead to the last question of physics. It's telling that the effective resistance of the parallel connection that consists of four wires, equal length, equal area cross section, and same material is found. Okay. It is R equivalent is given, and you know R equivalent is equals to R upon N simply. So you need to what will be the effective scissor connector in series? Okay, you from here you get that R equivalent is given, and that is 0.25. You know R, there are four, so 0.25 into 4. It will be 100 upon. It will be R will become 1. So answer will 4 ohm. Simple. From here you get R, and once you get R, all R in series. So 4R in series means 4R, and for 1R its value is 1 ohm. So total it will be 4 ohm. So these are the explanation. You can see the detailed explanation from the PDF. I just focus on your concepts and the analysis between it, so that you should, and also explain a little bit more so that you don't get confused to the new question which is asked based on this. I hope you understand the things. If you have any issue, you can comment me out. Okay, I will try to explain as possible. Okay. Thank you very much.